the race to build something unthinkable. In the late 1920s, the sky above Manhattan began to change. Buildings stretched upward, reaching higher and higher, as if the city itself was dreaming of touching the clouds. And in this era of ambition and possibility, a quiet competition was unfolding, a race that would captivate the world and push the boundaries of what seemed possible. Imagine for a moment, standing on the streets of New York in 1929. The air is filled with the sounds of construction, the rhythm of a city transforming itself. And among all this energy, two buildings are rising, each determined to claim a singular title, the tallest building in the world. The Chrysler Building, elegant and Art Deco in its design, was climbing steadily into the sky. Its architect, William Van Allen, had plans, secret plans to add a gleaming spire at the very last moment, a surprise that would push his creation past any rival. But there were others watching, others with their own dreams of height and grandeur. Enter two men, Alfred E. Smith and John J. Raskob. Smith, the former governor of New York, a man of the people with ambition that matched the scale of the city he loved, and Raskob, a financier, a numbers man who understood that in business, as in building, timing was everything. Together, they envisioned something extraordinary, not just a tall building, but the tallest, a structure that would stand as a testament to human achievement, to the possibilities of the modern age. And so the plans began. But this was no ordinary construction project. This was a race against time, against rivals, against the very limits of engineering and imagination. As the designs took shape, something remarkable happened. The team kept revising the height. First, the building would be 80 stories. Then, as word spread of the Chrysler Building's progress, the plans changed. 85 stories, then perhaps more. Each revision was a response, a move in this elegant chess game being played out in steel and stone against the Manhattan skyline. The architects and engineers gathered around drafting tables, their pencils sketching and resketching, always reaching a little higher. There was an energy to these meetings, a sense that they were part of something historic. Every foot mattered. Every inch could mean the difference between second place and immortality. And then someone had an idea, a brilliant, audacious idea that would solve the height question once and for all. What if the building didn't just end with a roof? What if it reached even further into the sky with a purpose, a function? What if they added a mooring mast, a place where dirigibles, those great airships of the era, could dock, floating above the city like dreams made solid? The mooring mast would add precious height to the structure. It would give them an advantage that no rival could easily match. More than that, it captured the imagination. It spoke to a future where travel happened not just on streets or rails, but through the air itself, with passengers stepping off an airship directly onto the top of the world's tallest building, high above the bustle of the city below. It was visionary. It was perhaps impractical, but it was exactly the kind of thinking that defined this project from the very beginning. Now, as these plans were being finalized, the world around them was changing in ways no one had quite anticipated. In October of 1929, the stock market crashed. The financial collapse sent shockwaves through every corner of American life. Fortunes vanished overnight. Construction projects were cancelled. The optimism that had defined the 1920s gave way to uncertainty and fear. The Great Depression had begun. Many would have stopped. Many did stop. Across the country, ambitious projects were abandoned, left as skeletal frames or empty lots, monuments to dreams deferred. But Smith and Raskob made a different choice. They decided to move forward, to build even as the economy crumbled around them. Perhaps especially because the economy was crumbling. There was courage in this decision, and perhaps something else too. A belief that the act of building itself mattered, that creating something magnificent could be its own form of hope, its own statement of faith in the future. The workers would need jobs, the city would need a symbol, and the world, watching, would need to see that even in the darkest times, human beings could still reach for the sky. And so, with plans finalized, in height secured, with a mooring mast designed, and nation struggling to find its footing. The stage was set. The race was on. The Empire State Building would rise, and it would rise quickly, in a display of speed and determination that would become legendary. But before any steel could be raised, before any stone could be set, there was ground to break and foundations to lay. The real work, the work that would test every assumption and push every worker to their limit, was about to begin. Designing at breakneck speed, there is something almost meditative about the act of drawing. The pencil moving across paper, lines forming shapes, shapes becoming structures. An architect's hand, guided by years of training and intuition, can transform a blank page into a vision of the future. But what happens when there's no time? When the deadline is not months away, but weeks? When the entire world is waiting and every day of delay means falling behind in a race you cannot afford to lose? This was the challenge facing William F. Lamb, the lead architect tasked with designing the Empire State Building. And what he accomplished in those early weeks remains, even now, almost difficult to believe. 2 weeks. Just 2 weeks to produce the core design drawings for what would become the world's tallest building. Imagine the pressure. Imagine sitting at that drafting table, knowing that the decisions you make in these fleeting days will determine the shape of something that might stand for generations. Every line matters, every calculation, every choice. But Lamb had something working in his favor. He had experience, he had knowledge, and perhaps most importantly, he had the wisdom to know that innovation doesn't always mean starting from nothing. Sometimes, the most brilliant solutions come from understanding what has worked before and building upon it, refining it, perfecting it. You see, this wasn't the first skyscraper Lamb had designed. His firm, Shreve, Lamb & Harmon, had created. Other tall buildings had solved similar problems before, and Lamb understood that he could draw upon these earlier designs. Not to copy them, but to use them as a foundation, a starting point that would save precious time without sacrificing quality or vision. Think of it like a musician who has practiced scales for years. When the moment comes to perform, to create something new, those fundamental patterns are already there, ingrained in muscle memory. The fingers know where to go. The mind is free to focus on the artistry, the nuances, the unique elements that will make this performance different from all others. And so Lamb worked, quickly but carefully, pulling from what he knew, adapting and transforming earlier ideas to meet the specific needs of this unprecedented project. The drawings emerged, sheet after sheet, each one capturing another aspect of the design, another detail of the vision. But Lamb wasn't working alone. His partner, Richmond Shreve, was engaged in his own form of architectural meditation, creating what came to be known as bug diagrams. These weren't the elegant elevation drawings you might picture when you think of architectural plans. They were something more practical, more essential. Imagine looking down at the building from above, floor by floor, with each space color-coded or marked to show its purpose. Offices here, mechanical systems there, elevator shafts running through the center like the building's spine. These diagrams were maps of function, showing how every square foot would be used, how people and systems would flow through the space, how the building would actually work as a living, breathing entity. Shreve would sit with these diagrams spread before him, thinking through the logic of the building. How many elevators would be needed? Where should they be placed? How wide should the corridors be? What about ventilation, plumbing, electrical systems? Every floor had its own puzzle to solve, its own balance of form and function to achieve. These bug diagrams might have seemed mundane, unglamorous compared to the soaring sketches of the building's exterior, but they were crucial. They ensured that the Empire State Building would be more than just a beautiful facade. It would be efficient, practical, a place where thousands of people could work comfortably every single day. Now, as Lamb and Shreve worked through these challenges, they were also grappling with something that shaped every tall building in New York: the 1916 zoning resolution. This was a law, passed more than a decade earlier, that changed the way architects thought about skyscrapers. You see, as buildings grew taller in the early 1900s, people began to worry. Would these massive structures block out all the sunlight? Would the streets below become dark canyons, forever in shadow? The 1916 law was designed to prevent this, requiring that as buildings rose higher, they had to step back, creating setbacks that would allow light and air to reach the street level. This meant that architects couldn't simply design a straight, vertical tower. They had to think in layers, in terraces, creating a form that tapered as it rose. And rather than seeing this as a limitation, the designers of the Empire State Building embraced it as an opportunity. They designed from the top, down, starting with the highest point, the crown of the building, and working their way down, ensuring that each setback was not just meeting the legal requirement, but enhancing the building's form. Each step back would be a deliberate choice, a sculpting of the structure's silhouette against the sky. And as these setbacks took shape on paper, something remarkable emerged. The building wasn't just tall, it was elegant. It had a grace to it, a sense of proportion that felt almost natural, as if the building had grown organically rather than being imposed upon the landscape. The setbacks gave the Empire State Building its iconic form, that distinctive profile, that would become instantly recognizable around the world. From certain angles, it would look like a series of stepped pyramids, each rising from the one below. From others, it would appear as a single soaring gesture, reaching confidently toward the clouds. This was the genius of the design. It satisfied the practical requirements of the zoning law. It provided functional spaces on every floor, and it created something beautiful, something that would capture the imagination and become a symbol not just of New York, but of human ambition itself. This, conceived and drawn in a matter of weeks, all of this, created under impossible pressure by architects who understood that speed and quality didn't have to be enemies, that with the right approach, with experience and creativity working together, even the most ambitious dreams could be captured on paper and made real. The designs were complete, the vision was clear. Now it was time to turn those drawings into steel and stone, to take what existed only in imagination and blueprints and bring it forth into the physical world. The real construction was about to begin. Clearing the ground and going deep. There is something profound about the act of clearing space. Before anything new can rise, something old must give way. Before the future can take form, the past must be carefully, respectfully dismantled. And in the heart of Manhattan, on Fifth Avenue between 33rd and 34th Streets, stood a piece of that past. Grand, elegant, filled with memories and stories. The Waldorf Astoria Hotel. For decades, this hotel had been a symbol of luxury and sophistication. Its halls had welcomed presidents and princes, artists and industrialists. Within its walls, deals had been struck, romances had bloomed, history had unfolded one quiet moment at a time. The Waldorf Astoria was more than just a building. It was an institution, a landmark, a place where New York society gathered and the world felt close enough to touch. But now, it stood in the way of something new. And so, the decision was made. The hotel would have to go. Demolition is often thought of as destruction, but there's an art to it, a careful choreography. Each piece must be removed in the right order, with attention paid to safety, to efficiency, to the rhythm of the work. And so, day by day, the Waldorf Astoria began to come down. Walls that had stood for decades were carefully dismantled. Fixtures that had gleamed under chandeliers were removed and catalogued. The grand staircase, the ballrooms, the ornate ceilings, all of it, piece by piece, making way for what was to come. Workers moved through the building like archaeologists, in reverse, taking apart layers of history. And as they worked, perhaps some of them paused occasionally, running a hand along a banister or standing for a moment in a doorway, acknowledging the weight of what they were undoing. The Waldorf Astoria would rise again elsewhere, in a new location, with new stories to tell. But this particular building, in this particular place, was coming to an end. And then finally, the sight was clear. Open sky above, solid ground below. And now, the real work could begin. But before anything could rise upward, they first had to go down. Down into the earth itself. carving out space for the foundations that would support the tremendous weight of the world's tallest building. The excavation began. Imagine standing at the edge of that excavation site as it deepened day by day. The sound of machinery echoing off the surrounding buildings, the smell of earth and diesel, the sight of that growing cavity, that absence carved into the Manhattan bedrock. Down they went, 50 feet, 55 feet, creating a vast basement that would eventually house mechanical systems, storage, and all the infrastructure needed to keep the building functioning. 55 feet. That's the height of a 5-story building, but in reverse. A negative space, a foundation not just for the structure above, but for all the systems that would make modern life possible within it. Think of the scale of that excavation, the tons of earth and rock removed. The precision required to create walls that were straight and true, to ensure that everything above would rest on something absolutely solid. And here, the builders encountered something extraordinary, something that would make their work both easier and possible in ways it might not have been anywhere else in the world. Manhattan schist. Schist is a type of metamorphic rock, formed deep in the earth under incredible heat and pressure over millions of years. It's dense, strong, remarkably stable. And crucially, in Manhattan, it lies relatively close to the surface in certain areas. On this particular site, the bedrock was accessible, reachable, solid as the planet itself. This was a gift, though it might not have seemed like one to the workers whose tools struck it, whose machines ground against its surface. But for the engineers, for those thinking about how to support an 102-story building, this bedrock was everything. It meant they could use spread footings, a foundation design that distributes the weight of the structure across a wider area of rock, rather than requiring deep pilings driven far into softer soil. Spread footings are elegant in their simplicity. Picture a pyramid, inverted, with its U point at the top, supporting a column of steel, and its base spreading wide against the bedrock below. The weight of the building presses down, and the bedrock pushes back. And between these two forces, there is balance, stability, permanence. The presence of Manhattan schist meant the foundation work could proceed faster. No need for the time-consuming, expensive process of driving pilings hundreds of feet down into softer ground. Instead, they could excavate to the schist, prepare it carefully, and build their footings directly upon it. Time saved, money saved, and most importantly, confidence gained. The builders knew they were anchoring their dream to something that had been there for eons and would remain for eons more. But the footings alone weren't enough. The building's steel frame would rest on columns, and each column needed its own pier. A vertical shaft sunk into the bedrock, filled with concrete, creating individual pillars of support. These pier holes were drilled with care, each one positioned precisely according to the architectural drawings, each one tested to ensure it reached solid rock. Think of the patience required for this work, the attention to detail. Each pier hole had to be exactly right, because once the concrete was poured, there would be no going back, no adjustments. The entire steel frame of the Empire State Building would rest on these foundations, and they had to be perfect. And so the concrete was mixed and poured, filling those pier holes, creating hundreds of vertical supports rooted in the ancient bedrock. As the concrete cured, it bonded with the schist, becoming part of the geological structure of Manhattan itself. The Empire State Building wouldn't just stand on the island, it would become part of it, anchored to the very bones of the earth. This foundation work happened largely out of sight. Passers-by on Fifth Avenue couldn't see the pier holes being drilled or the footings being poured. They saw only the construction fencing, heard only the muffled sounds of work happening below street level. But this invisible work was essential, the foundation upon which everything else would depend. There's a kind of faith required in construction, especially at this stage. The foundation will never be seen once the building is complete. It will be buried, hidden, forgotten by everyone except the engineers who designed it and the workers who built it. And yet it's what makes everything else possible. Without it, even the most beautiful design, the most innovative engineering, the most skilled craftsmanship would come to nothing. And now, with the excavation complete, with the bedrock reached, and the foundations poured, with the site prepared and the groundwork finished, the stage was set for the next phase. The steel was ready to rise. The real vertical construction, the part that would capture the world's attention and imagination, was about to begin. The race upward was on. Turning construction into an assembly line. There is a rhythm to great construction, a kind of music in the coordination of countless moving parts. But creating that rhythm, maintaining that flow across hundreds of workers and thousands of pieces, that requires something more than instinct. It requires planning of a depth and precision that most people never see, never consider. And for the Empire State Building, that planning would become legendary. The construction firm chosen for this monumental task was Starrett Brothers and Eakin. They were builders with a reputation, yes, but more than that, they were thinkers. They understood that constructing the world's tallest building in record time wasn't just about working harder or faster. It was about working smarter. It was about reimagining the entire process of construction itself. And so, they created something that might seem unremarkable today, but was revolutionary then. Scheduling charts, detailed, comprehensive maps of time itself, showing not just what needed to happen, but when and in what order and how long each task would take. Picture a wall, covered in these charts, lines and boxes, dates and deadlines, each task connected to the next in an intricate web of dependencies. If the steel arrives on Tuesday, then the riveting can begin on Wednesday, and the facade work can start on Friday, and so on, cascading, forward in time, like dominoes carefully arranged to fall in perfect sequence. But these weren't just schedules. They were predictions, carefully calculated guesses about how the future would unfold. And they required an understanding not just of construction, but of human nature, of weather patterns, of supply chains, of all the thousand small things that could go right or wrong on any given day. The innovation wasn't just in creating these schedules, it was in what the schedules made possible. Overlapping phases of work. You see, traditionally, construction happened in strict sequence. You finished the foundation completely before starting the steel frame. You finished the frame completely before starting the facade. One thing at a time, each phase waiting for the previous one to be entirely done. But Starrett Brothers and Eakin realized something crucial. What if you didn't wait? What if, as soon as the foundation was solid enough on the lower floors, you started raising steel there, even while excavation and foundation work continued on other parts of the building? What if multiple phases of construction could happen simultaneously, carefully choreographed, so they didn't interfere with each other, but instead created a continuous flow of progress? It was like conducting an orchestra, where different sections started playing their parts at different times, but all moving toward the same grand finale. The foundation crew worked below, while the steel crew worked above. The facade installers followed close behind the steel workers, sometimes only a few floors back. Electricians and plumbers moved through floors that were still being enclosed, installing systems while painters worked a level below them. This overlapping approach meant that the building was always progressing on multiple fronts simultaneously. No waiting, no idle time, just constant, relentless, carefully coordinated motion upward. But making this possible required something else, something that was just beginning to transform American industry: prefabrication. The steel arrived at the site not as raw beams to be cut and shaped, but as finished components, precisely fabricated in distant mills to exact specifications. Each piece was measured, cut, drilled for rivets, marked with its position in the structure. Some pieces came from Pittsburgh, others from Bethlehem, Pennsylvania. Each one traveling hundreds of miles, arriving at exactly the right moment, ready to be lifted into place and joined to its neighbors. Think about the planning this required. The steel had to be ordered months in advance, fabricated by workers who would never see the building they were helping to create, shipped on trains that had to run on time, delivered to a congested city block where storage space was minimal, and every square foot was precious. There was no room for error. If a beam arrived late, the entire schedule could cascade into chaos. If a piece was fabricated incorrectly, it might not fit, and valuable time would be lost making corrections. And yet somehow it worked. Day after day, the steel arrived, was unloaded, was hoisted into the air and found its place in the growing structure. The facade components were similarly prefabricated. Limestone panels, cut and finished in Indiana quarries. Metal window frames, manufactured to precise dimensions, each piece traveling its own journey to reach this one construction site, this one moment in time when it would be needed. Materials arrived from multiple regions, a web of supply chains all converging on 34th Street and 5th Avenue. It was a logistical ballet, a demonstration of what modern transportation and communication could achieve when properly orchestrated. Trucks and trains, telegrams and telephone calls, all working together to keep the construction site supplied with exactly what it needed, exactly when it needed it. And then there was perhaps the most audacious aspect of this entire approach, the interior layouts and material orders. In a traditional project, these would be finalized months in advance. Detailed drawings would show every wall, every door, every fixture. But Starrett Brothers and Eakin realized that early decisions often had to be changed later, leading to waste and rework. So they did something almost unthinkable. They waited. They finalized the interior layouts for each floor just hours before installation began. This meant the architects and engineers had to work right alongside the construction crews, making decisions in real time, adapting to conditions as they found them, ordering materials with barely any buffer time for error. It sounds chaotic, and perhaps it was in its way, but it was also brilliantly efficient. No materials ordered too early and sitting idle. No layouts locked in before anyone knew what the actual conditions would be. Instead, a fluid, adaptive process that responded to reality rather than trying to predict it perfectly months in advance. This approach required trust. The workers had to trust that the materials would arrive. The suppliers had to trust that their work would be needed. The architects had to trust that their last-minute decisions would be sound. And everyone had to trust in the system, in the schedules, in the careful planning that made this seemingly spontaneous construction possible. What emerged from all this planning and coordination was something that looked, from the outside, almost effortless. The building rose with a speed that seemed impossible, magical even. But it wasn't magic. It was logistics. It was scheduling. It was the careful application of assembly line thinking to a project far more complex than any automobile or appliance. Henry Ford had shown that you could build cars faster by bringing the work to the workers on a moving line. Starrett Brothers and Eakin showed that you could build a skyscraper faster by bringing the materials to the workers at precisely the right moment, creating a vertical assembly line that stretched into the sky. And as the spring of 1930 gave way, into summer, as the steel continued to climb and the facade continued to follow close behind, the world watched in amazement. The Empire State Building was rising faster than anyone had thought possible. The careful planning, the overlapping phases, the prefabrication, the just-in-time material deliveries, all of it was working, coming together in a demonstration of what organized human effort could achieve. The race was being won, not just through speed, but through intelligence, through planning, through the transformation of construction into something closer to industrial production. And the building climbed higher, day by day, reaching for a height that would soon surpass all rivals. The steel skeleton rises. There are moments in human endeavor when everything comes together, when months of planning crystallize into action, when the theoretical becomes tangible and dreams take on weight and form. For the Empire State Building, that moment arrived with the first pieces of steel lifted into the spring air above Manhattan. 57,000 tons of structural steel. Try to imagine that weight. 57,000 tons. It's difficult for the mind to grasp such a number, to translate it into something we can truly feel. But picture this. Each piece of steel, from the massive columns to the smaller beams, all of it together weighing as much as a small fleet of ocean liners. And all of it would rise piece by piece into the sky, forming the skeleton upon which everything else would depend. The steel arrived constantly, delivered on trucks that threaded through the crowded streets of Manhattan, pulling up to the construction site where cranes waited to receive their cargo. Each beam was tagged, numbered, identified, so that workers would know exactly where it belonged in the grand three-dimensional puzzle they were assembling. And then the lifting began. The sound of it, the groan of cables taking the weight, the diesel engines of the cranes roaring, the shouts of workers guiding the beams through the air. Steel rising, turning slowly, moving through space with surprising grace despite its mass, until it reached its designated position and settled into place with a satisfying clang. But the steel didn't just rest there, balanced precariously on other beams. It had to be joined, permanently and powerfully, to create a frame that could withstand not just its own weight, but the weight of everything that would come after. The concrete floors, the facade, the mechanical systems, the thousands of people who would fill the building each day, even the force of winds that would press against its height. The technology that made this possible was riveting. Hot riveting, a process that was, in its own way, a kind of alchemy. Teams of workers, usually 4 to a crew, moving through the steel skeleton with practiced efficiency. One worker heating the rivets in a portable forge until they glowed orange-red. Another catching the hot rivet in a metal cup, then quickly positioning it in the pre-drilled holes that aligned 2 pieces of steel. The third holding a heavy backing bar against one end of the rivet, and the fourth wielding a pneumatic hammer, pounding the hot rivet until it mushroomed on both ends, filling the hole completely and binding the steel pieces together. As the rivet cooled, it contracted, pulling the steel pieces even tighter together. The result was a connection stronger than the steel itself, a joint that would hold for as long as the building stood, and there were thousands upon thousands of these rivets, each one driven by hand, each one a small act of craftsmanship multiplied across the entire structure. The sound of riveting became the dominant voice of the construction site, a rhythmic hammering echoing off the surrounding buildings, a percussion that announced to the entire neighborhood that something extraordinary was taking shape. People blocks away could hear it, that steady beat of metal on metal, and know that the Empire State Building was growing taller. But how to lift all that steel? How to raise tons of material hundreds of feet into the air efficiently, quickly, without stopping to reconfigure equipment every few floors? The answer was ingenious: relay derricks. These weren't cranes sitting on the ground, their reach limited by their height and the length of their booms. Instead, these derricks were mounted on the structure itself. As the building grew, the derricks grew with it, climbing the steel skeleton like mechanical spiders, ascending a web. Picture a derrick on, say, the 30th floor, lifting steel from a lower level and swinging it into position. Then, as work progressed above that point, the derrick would be disassembled, hoisted up to the 40th floor, and reassembled there, ready to continue lifting. Or sometimes multiple derricks worked in relays, passing materials up from one level to another, each one raising the steel a portion of the way, creating a chain of mechanical hands reaching ever higher. This system meant the derricks were always exactly where they needed to be, at the leading edge of construction, able to supply materials to the workers at the highest points without the inefficiency of trying to lift everything from ground level. It was another example of the kind of innovative thinking that characterized the entire project. Don't accept limitations. Find ways around them, and with these systems in place, with the workers skilled and coordinated, with the materials arriving on schedule and the weather cooperating, something remarkable happened. The building began to rise at a pace that seemed almost impossible. July 1930, 22 stories erected in 22 working days. Think about that. 1 story per day. Not 1 story started per day, but completed. Fully framed, steel set and riveted, ready for the next level to begin. It was a pace that had never been achieved before. A rate of vertical construction that caught the attention of engineers and builders around the world. How was it possible? It came down to everything we've discussed. The planning, the prefabrication, the overlapping phases, the relay derricks, the skilled workers who knew their jobs so well they could perform them almost instinctively. But it also came down to something else, something harder to quantify. There was a spirit on that site, a sense among the workers that they were part of something historic, that their labor was being watched and would be remembered. They worked through summer heat, through rain, through winds that made the high steel sway and flex beneath their feet. And they kept building. At peak pace, the structure rose by 4 to 4.5 stories per week. Every week, week after week, the skyline of Manhattan transformed before the city's eyes. Pedestrians on Fifth Avenue would look up and swear the building was taller than it had been that morning. Photographers set up time-lapse cameras to capture the ascent, creating images that compressed months of work into seconds, showing the steel skeleton shooting upward like a plant in accelerated growth. The workers moved through this vertical, in world with a confidence born of skill and necessity. They walked on beams barely a foot wide, hundreds of feet above the street, with nothing but empty air beneath them. They caught hot rivets thrown from 20 feet away. They operated the derricks with precision, swinging tons of steel through narrow gaps, placing beams exactly where they needed to go. It was dangerous work, demanding work, but it was also, in its way, beautiful work. And then in late 1930, after months of continuous construction, after 57,000 tons of steel had been lifted, positioned, and riveted into place, the moment arrived. The final beam was ready to be set. The top of the steel frame had been reached. There's a tradition in construction, an old ritual that marks this moment, the topping out. The final piece of steel, often painted white or adorned, with an evergreen tree, a symbol of life and growth, is lifted and set with ceremony. Workers gather, photographs are taken, and for a brief moment, everyone pauses to acknowledge what has been achieved. For the Empire State Building, this ceremony carried special weight. They had done it. They had built the steel frame of the world's tallest building, and they had done it faster than anyone had thought possible. The skeleton was complete, rising 1,250 feet into the sky, waiting now for the skin and systems that would transform it from a framework of steel into a functioning building. But even in this moment of celebration, the work didn't stop. The floors below were already being enclosed. The facade was being installed. The mechanical systems were being fitted into place. The relay derricks, which had climbed with the structure to this height, would now reverse their journey, being lowered floor by floor as the work below them was completed and their services were no longer needed. The steel skeleton had risen, but it was only one part of the story. The building was still incomplete, still a promise waiting to be fully realized. And yet, standing there, looking at that framework against the sky, anyone could see what it would become. The form was there, the height was there, the ambition made manifest in metal. The hardest part, in some ways, was done. The race upward had been won. Now came the patient work of completion, of transforming this skeleton into a place where life and work and human activity could flourish high above the city streets. Feeding a vertical city, a building under construction is, in its own way, a kind of living thing. It breathes through its open floors, it grows day by day, and like any living thing, it must be fed. But feeding a structure as large as the Empire State Building, rising hundreds of feet into the air, presented challenges unlike any faced before. This wasn't just a building site, it was a vertical city under construction, and keeping it supplied with everything it needed required logistics on a scale that bordered on the miraculous 200 trucks. More than 200, actually, arriving every single day at the construction site on Fifth Avenue. Picture that for a moment. Picture the narrow streets of Manhattan, already crowded with automobiles and pedestrians, trolley cars and delivery wagons. And into this urban tapestry, add more than 200 additional trucks, each one bringing materials essential to the construction. Steel beams and window frames, bags of cement and bundles of electrical wire, limestone panels and plumbing, fixtures, timber and tile, and 1,000 other items. The traffic alone could have brought the project to a halt. If those trucks had simply arrived randomly, parking wherever they could, unloading at their leisure, the resulting chaos would have made efficient construction impossible. But remember, this project was built on planning, on schedules, on the careful orchestration of every element. Each truck had a designated time slot, a specific window when it was expected to arrive. Dispatchers tracked deliveries, coordinating with suppliers across multiple states to ensure materials arrived not just on the right day, but at the right hour. As one truck finished unloading and pulled away, another was already approaching, ready to take its place. It was a ballet of logistics, a continuous flow of materials from the wider world into this one concentrated point of construction. But getting the materials to the site was only the first challenge. Once they arrived, they had to be moved into the building, distributed to the floors and locations where they were needed. And here, the builders demonstrated the same innovative thinking that had characterized every aspect of the project. Consider the bricks. Millions of bricks were needed for interior walls, for partitions, for the countless small structures within the building's steel frame. Bricks are heavy, awkward to carry in large quantities, and the building required them on every floor, from the basement to the upper stories. Carrying them manually would have been impossibly slow and inefficient, so instead, a system was devised. In the basement, workers loaded bricks into chutes, vertical shafts that ran through the building like veins. Gravity did the work of moving bricks downward when needed, but for upward distribution, a different approach was required. Internal rail systems were installed, temporary tracks that allowed small carts to be pushed or pulled through the building's corridors and spaces. These weren't grand railways, they were narrow-gauge lines, miniature versions of the trains that crisscrossed the continent. Some called them mini railroads, and the name captured both their function and their charm. A worker could load a cart with bricks or mortar or tools, then push it along these tracks to wherever it was needed. The wheels rolling smoothly over the rails, making the work just a little easier, just a little faster. Picture these little trains moving through the building's interior, passing through doorways and around corners. Each one carrying its cargo to construction crews who were waiting, ready to continue their work. It was a simple solution, elegant in its practicality, and it kept the materials flowing, kept the work progressing without interruption. But the real challenge was vertical movement. How do you efficiently move thousands of tons of material upward through a building that's still being constructed? The relay derricks handled the heavy steel, yes, but what about everything else? The smaller items, the bags of cement, the bundles, if wire, the window frames and door panels. The answer was hoists and temporary elevators. Even before the building's permanent elevator system was installed, temporary lifts were put in place, running through the core of the structure. These weren't the sleek, passenger-ready elevators that would eventually carry workers and visitors. These were industrial lifts, simple platforms enclosed in temporary shafts, designed to carry materials rather than people. All day long, these hoists ran continuously, rising and descending, each trip bringing materials upward or removing debris downward. Workers loaded materials at ground level or in the basement, then signaled to the operator. The hoist would rise floor after floor until it reached the level where those materials were needed. The load would be unloaded, the hoist would descend, and the cycle would begin again. There was a rhythm to it, a constant mechanical heartbeat at the center of the building. Up and down, loaded and empty, the hoists never stopped during working hours. They were the building's circulatory system, carrying what was needed to where it was needed, enabling work to proceed simultaneously on multiple floors without workers having to wait for materials. And then there was the facade, the skin of the building that would enclose the steel skeleton and give the Empire State Building its finished appearance. Limestone panels, each one carefully cut and finished in distant quarries, each one fitted with metal clips and supports. These panels, known as curtain wall panels, hung on the steel frame like fabric on a dress form, not supporting the building's weight, but covering it, protecting it, defining its appearance. Installing these panels was delicate work. Each one had to be positioned precisely, aligned with the panels around it to create a seamless surface. Any error would be visible, a break in the smooth rhythm of the facade, and perfection was not optional on a building that would be this prominent, this closely observed. And yet, despite the precision required, the curtain wall went up at a pace of roughly 1 story per day, every day. workers completed the facade on an entire floor. 30,000 square feet or more of surface area enclosed, windows set, limestone panels secured. It was a pace that matched the steel frame's earlier ascent, a demonstration that the same principles of efficiency and coordination could be applied to any phase of construction. Think about what 1 story per day means. It means that as you went to sleep at night, the building looked one way, and when you woke the next morning and looked up at it from the street, it had changed. Another floor completed, another level enclosed. The transformation was visible day by day, a progress you could actually see unfolding before your eyes. The workers installing the facade developed their own rhythms, their own efficient procedures. They worked from platforms suspended outside the building, with the city spread out below them and the sky above. The wind would blow at these heights, making their work harder, but they persisted. Panel by panel, floor by floor, they clothed the steel skeleton, transforming it from an abstract framework into something recognizable as a building. And through all of this, the supply chain never broke. The 200 trucks kept arriving. The internal rail systems kept moving materials horizontally. The hoists kept lifting vertically. The curtain wall kept climbing. Everything flowed, everything connected, everything worked together in a system, so complex and yet so smoothly functioning that it appeared almost effortless. But it wasn't effortless. It was the result of constant attention, constant coordination, constant problem-solving by the hundreds of people who made the construction, inside their workplace and, in some ways, their home. They lived inside this vertical city they were building, moving through its spaces, learning its geography, becoming part of its story. And as the summer of 1930 turned to fall, as the facade climbed higher and higher, approaching the steel frame's peak, the building began to look less like a construction site and more like what it would become. The promise was being fulfilled. The vision was taking its final form, and the workers who had fed this vertical city, who had kept it supplied and growing, could see their labor reflected in every panel, every window, every completed floor. The building was almost ready, almost complete, but there were still systems. To install, interiors to finish, 1,000 details that would transform this structure from an empty shell into a functioning workplace. The feeding would continue, but now the focus would shift from raw materials to the finishing touches that would make the Empire State Building not just the tallest, but also one of the most modern and efficient buildings in the world. Building from the inside out. When we imagine construction, we often picture it happening in stages. First the foundation, then the frame, then the exterior, and finally, when everything else is complete, the interior work begins. But that's not how the Empire State Building came to be. While the world watched the steel skeleton rise and the facade climb higher, another transformation was happening inside, largely invisible to observers on the street, but just as essential to the building's completion. The interior trades followed just days behind the steel crews. Days, not weeks or months. As soon as a floor's steel frame was in place and riveted secure, as soon as the concrete floor was poured and had cured enough, to support workers and equipment, the interior specialists moved in. Plumbers and electricians, heating engineers and elevator installers, each with their own crucial role to play in transforming empty floors into functional space. Imagine being one of these workers, arriving on a floor where, just days before, there had been nothing but open air and steel beams. The concrete beneath your feet is still fresh, the edges rough and unfinished. Above you, you can see straight through to the sky through the floors that aren't yet enclosed. The wind blows through freely, carrying the sounds of construction from above and below. And in this raw, unfinished space, you begin your work. The plumbers came first, in many cases. They had to install the vertical supply and waste lines, the arteries and veins that would carry water up through the building and waste back down. These lines had to be positioned precisely, running through spaces that would eventually be hidden behind walls and ceilings, but for now existed in the open, exposed to view. It was intricate work, requiring knowledge not just of plumbing but of the building's overall design. Where would the bathrooms be? Where would the drinking fountains be placed? Every fixture, every connection had to be planned and installed, so that it would work properly, not just on this floor, but in coordination with all the floors above and below. And the plumbers couldn't wait until the building was finished to test their work. They needed water now on these upper floors, both to verify their installations and to support the ongoing construction. So temporary water taps were installed, simple spigots connected to the rising water lines, providing fresh water hundreds of feet in the air. Workers could drink from these taps, could fill buckets for mixing mortar, could wash off the day's grime without having to descend to ground level. The electricians worked parallel to the plumbers, threading wires through the structure, installing junction boxes and conduits. Every office would need power, every corridor would need light. The electrical system had to be comprehensive, redundant in critical areas, and above all, safe. Faulty wiring in a building of this size could lead to catastrophe, so the work was done with meticulous attention to standards and codes. But this wasn't just about basic electricity. The Empire State Building would be modern in every sense, equipped with the latest technology. That meant telephone lines throughout, intercoms for communication between floors, signal systems for emergencies. All of this had to be wired and tested while the building was still under construction. Cables snaking through spaces that workers navigated by temporary lighting, shadows and brightness alternating as you moved through the unfinished floors. The heating engineers faced their own unique challenges. A building this tall creates its own climate, with temperatures varying significantly between lower and upper floors. Wind pressure at the top is intense, making heating in winter and cooling in summer more difficult. The system had to be designed to handle these variations, to maintain comfortable temperatures throughout the building, regardless of the season or the floor. Steam radiators were installed, massive pipes running vertically through the building to distribute heat. Boilers in the basement would generate the steam, which would rise through these pipes to warm every floor. The engineering required was complex, accounting for pressure differentials and the physics of steam at various heights. But when completed, it would allow the building to be occupied comfortably year-round, a necessity for a structure intended to house thousands of workers. And then there were the elevators. In a building this tall, elevators weren't just a convenience. They were essential. You couldn't expect people to climb 80 or 90 flights of stairs multiple times a day. The elevator system had to be fast, reliable, and capable of moving thousands of people efficiently during peak hours. 67 elevators would eventually serve the building, divided into different groups serving different zones of floors. Express elevators would shoot from the lobby to sky lobbies, where passengers could transfer to local elevators that served smaller ranges of floors. It was a system that had been refined in earlier skyscrapers, but would reach its most sophisticated implementation yet in the Empire State Building. Installing these elevators while the building was still under construction was a remarkable feat. The elevator shafts had to be maintained and protected as the building rose. The machinery, some of it weighing tons, had to be hoisted into place and precisely installed. The control systems, the safety mechanisms, the doors on every floor, all of it had to be coordinated and tested to ensure that when the building opened, the elevators would work flawlessly. As all this technical work progressed, something unexpected emerged inside the unfinished building: small cafes and food concessions. The workers needed to eat, yes, but descending to street level for lunch would waste time and energy. So enterprising vendors set up shop inside the structure itself, creating temporary restaurants on various floors. Picture this. You're working on the 70th floor, installing electrical conduit. The lunch whistle sounds, echoing through the steel framework. You set down your tools and walk to a makeshift cafe that's been set up in one corner of the floor. There are simple tables, perhaps just planks laid across sawhorses. A vendor serves hot coffee and sandwiches, soup on cold days. You sit with your crew, eating lunch within view of the city spreading out below through the open sides of the not yet enclosed floor. The wind blows, carrying smells from the street far below. But up here you have your meal, sharing stories and jokes with your fellow workers before returning to the job. These cafes were more than just convenient. They were community spaces, places where workers from different trades could interact. where the isolation of working in different parts of such a vast structure could be briefly overcome. They made the building site feel less like a harsh industrial environment and more like a place where people worked and lived together, even if temporarily. Meanwhile, in the lower floors, attention was being paid to the spaces that would define the building's public image. The lobby, in particular, required careful coordination between the structural grid of steel columns and the desire to create grand, column-free spaces where people could move freely. The structural engineers and architects worked together to find solutions. Some columns could be eliminated by transferring their loads through beams to adjacent columns. Others could be pushed to the edges or incorporated into walls. The goal was to create a sense of openness, of grandeur, that would make entering the Empire State Building feel special, important. The materials for the lobby were chosen with care. Marble for the walls, polished and gleaming. Metalwork in Art Deco designs, celebrating the machine-age aesthetic that defined the era. Lighting fixtures that would cast warm, welcoming light across the space. Every detail was considered, every choice made to support the building's identity as not just the tallest, but also the most magnificent. And as these public spaces took shape alongside the technical installations, as the plumbing flowed and the electricity hummed and the elevators began their test runs, the building transformed. What had been an empty skeleton of steel became a space that could support human activity, human life. The workers moved through these transforming spaces with practiced efficiency, each trade knowing its role, each team coordinating with the others to ensure that their work didn't conflict, but instead complemented and supported what came before and after. It was construction as collaboration, building as a shared endeavor involving hundreds of skilled individuals all working toward the same goal. And day by day, floor by floor, the interior of the Empire State Building came to life. Water flowed to the upper floors through the plumbers' carefully installed lines. Lights flickered on as the electricians completed their connections. The heating system was tested, filling the spaces with warmth. The elevators began their journeys up and down, carrying workers and materials, practicing the routes they would eventually travel thousands of times per day. The building was becoming what it was meant to be, not just a structure, but a place. A place where people would work and meet, where business would be conducted and decisions made, where the daily rhythm of urban life would unfold hundreds of feet above the streets. The inside was ready, or nearly so, waiting now for the finishing. Touches that would complete the transformation from construction site to functional workplace. The men in the sky buildings don't rise on their own. Steel doesn't lift itself into place. Behind every great structure, there are people, individual human beings with names and families, with hopes and fears, with skills honed over years of practice. In the Empire State Building, for all its engineering marvels and innovative logistics, was ultimately built by the hands and hearts of the men who climbed into the sky day after day to make it real. At the peak of construction, between 3,000 and 3,500 workers moved through the building site every day. Imagine that number. Picture 3,000 people, each with their own task, their own role to play. Riveters and steel workers, plumbers and electricians, carpenters, and stonemasons, crane operators and foremen, inspectors and engineers. A small city's worth of people, all converging on this one location, working together toward this singular goal. They came from everywhere. Many were immigrants, men who had traveled across oceans to find work in America, bringing with them skills learned in the old country. Irish stonemasons who had apprenticed in their youth on buildings centuries old. Italian artisans who understood marble and terrazzo with an intimacy passed down through generations. German engineers trained in the technical schools of Europe. Each brought their own traditions, their own approaches, and these merged into the American style of construction that was rapidly evolving during these years. Among the steelworkers, there was a particular group that gained fame for their fearlessness and skill, the Mohawk ironworkers. These men, from the Kanawake Reserve near Montreal, had developed a reputation for their comfort working at great heights. Perhaps it was cultural, a tradition of accepting dangerous work without hesitation. Or perhaps it was simply economic, necessity that made them willing to take risks others wouldn't. Whatever the reason, they became legendary, sought after for the most challenging high-steel work on skyscrapers across North America. They walked the beams with a casual confidence that amazed observers. Hundreds of feet in the air, with nothing but empty space below. They moved along steel beams barely a foot wide, as easily as most people walk down a sidewalk. They didn't creep or shuffle. They walked normally, sometimes even running when speed was needed, trusting their balance and their training absolutely. The other workers called them Sky Boys and Iron Men, nicknames that captured both their youth. Many were in their 20s, and their almost superhuman-seeming ability to work in conditions that would terrify most people. They wore these names with pride, seeing in them recognition of their skill and courage. But it wasn't just the Mohawk workers who earned these names. Any man working on the high steel, regardless of his background, could be called a Skyboy or an Iron Man. It was a mark of respect, an acknowledgement of the dangers they faced and the skill required to face them successfully. And there was someone there to capture their work, to document these men in the sky for posterity. Lewis Hine, a photographer with a deep commitment to social documentation, was hired to photograph the construction. But Hine didn't just take pictures from the ground, looking up at distant figures. He climbed with the workers, bringing his heavy camera equipment up onto the high steel, positioning himself in the most precarious places to get the shots he wanted. The resulting photographs are remarkable, haunting even. They show men sitting casually on steel beams, eating their lunches with their legs dangling over empty space. The city spread out far below like a toy landscape. They show workers guiding beams into place, their bodies leaning out over the void to reach their work. They show the concentration on their faces, the ease in their postures, despite the danger surrounding them. One photograph in particular has become iconic. A group of ironworkers sitting along a beam during their lunch break, unwrapping sandwiches and thermoses, while hundreds of feet of empty air stretches below them. They're talking, laughing even, as comfortable on that beam as you might be sitting on a park bench. It's an image that captures both the danger of their work and their remarkable composure in the face of it. Hine's photographs revealed something else too. The minimal safety equipment these men worked with. By modern standards, their protection was almost non-existent. No harnesses, no safety lines, no nets strung below to catch anyone who might fall. Just the men, the steel, and their own skill and balance keeping them safe. Some workers wore leather caps or simple hard hats, early versions, of the safety helmets that would become standard in later decades. But many worked bareheaded or with just a cloth cap against the sun. Their clothes were ordinary workwear, denim pants and heavy shirts, sturdy boots with leather soles that could grip the steel. Nothing specialized, nothing designed specifically for the dangers they faced. The lack of safety equipment wasn't callousness on the part of the builders. It was simply that the technology hadn't yet been developed, or the regulations requiring it hadn't yet been written. This was 1930, and workplace. Safety was just beginning to be taken seriously as a societal concern. The workers accepted the risks as part of the job, part of what it meant to be an iron worker in that era, and yet remarkably, the fatality rate on the Empire State Building construction was lower than on many other large projects of the era. 5 men died during the construction, each death a tragedy, but far fewer than might have been expected on a project of this scale and complexity. It suggests that despite the lack of formal safety equipment, there was a culture of caution, of watching out for one another, of not taking unnecessary risks. The workers developed their own safety practices, informal rules passed from experienced men to newcomers. Don't hurry on the beams, always keep your center of gravity low. Be aware of the wind, watch for ice in winter. Keep your tools secured so they don't fall and injure someone below. These lessons, learned through years of collective experience, kept most men safe even without harnesses or nets. There was also a bond among these workers, a sense of shared purpose and mutual dependence that went beyond mere co-workers. When you work at such heights, when your life might depend on your partner's attention or quick reflexes, you develop a deep trust. The riveting crews, working in teams of 4, developed rhythms of communication that were almost telepathic. The crane operators learned to read the hand signals of the workers below with absolute precision. Everyone watched out for everyone else, because everyone's safety depended on it. During lunch breaks, the men would gather in groups, finding whatever shelter they could from the wind and weather. Some ate in the temporary cafes we mentioned earlier. Others simply sat on the steel itself, unwrapping lunches packed that morning by wives or mothers or their own hands. They talked about their work, about their families, about their plans for when this job was done. They shared cigarettes and stories, creating a community in the sky. And when the day ended, when the whistle blew signaling the end of the shift, they descended. Down the temporary stairs or in the work elevators, back to ground level where the air was thicker and warmer, where solid earth beneath your feet felt strange after a day spent on narrow beams. They punched their time cards, collected their pay, and headed home to apartments scattered across the city to rest and prepare to climb back into the sky the next morning. These men, these thousands of individuals, were the true builders of the Empire State Building. The architects drew the plans and the engineers solved the problems, yes. But it was the workers who made it real, who transformed drawings into steel and stone, who took the risks and did the labor that turned vision into reality. Their names, most of them, are lost now. History remembers the prominent figures, the Smith and Raskob, the architects and engineers. But the iron workers and riveters, the plumbers and electricians, they fade into anonymity. Their individual contributions absorbed into the collective achievement. Yet without them, without each of those 3,000 workers bringing their skill and courage to the job site every day, the Empire State Building would never have risen. They were ordinary men doing extraordinary work. They were immigrants and natives, young men and experienced veterans, risk-takers and careful craftsmen. They were human, fully and completely human, with all the frailty and strength that implies. And they built something that has endured, that stands today as a testament not just to engineering and planning, but to the courage and skill of the men who worked in the sky. Cost, risk, and the human price. Every great achievement carries a cost. Sometimes that cost is measured in dollars and time, but sometimes it's measured in something far more precious, in human suffering, in lives altered or ended, in risks taken that didn't turn out well. And while we marvel at the Empire State Building's construction, while we celebrate its speed and efficiency, it's important to pause and acknowledge the human price that was paid to make it possible. The official records speak of 5 deaths during the construction. 5 men who went to work one morning and didn't return home. 5 families who received the news that no family wants to hear. 5 lives ended in the pursuit of building something taller and grander than anything built before. But the truth is, the exact number may never be fully known. Record-keeping in that era was less comprehensive than it would later become. Different sources cite different numbers. Some historical accounts suggest there may have been more than 5 deaths. Others confirm the 5. The discrepancy itself tells us something about how these men were valued, or perhaps not valued in the moment. Their deaths were noted, yes, but not with the kind of meticulous attention that we might expect today. What we do know is that the primary dangers were falls and falling debris. Working at such heights, walking on narrow beams, leaning out over empty space to position materials or drive rivets, every moment carried risk. A momentary loss of balance, a tool slipping from a hand, a piece of steel not properly secured. Any of these could lead to tragedy. Falls from high steel are almost always fatal. The human body simply isn't designed to survive impact from such heights. And for the workers, this knowledge was always present, always hovering in the background, if their consciousness, even as they worked with apparent ease and confidence. They knew what could happen. They had seen it happen to others on other job sites, and yet they returned day after day because the work needed doing, and they were the ones with the skills to do it. Falling debris posed a different kind of danger, one that threatened workers on lower levels, or even people passing on the street below. A dropped tool, a dislodged brick, even a rivet that missed its target. Anything falling from hundreds of feet up becomes a deadly projectile. The builders tried to minimize these risks, establishing protocols for securing tools and materials, creating protected walkways for pedestrians below. But in the chaos and intensity of rapid construction, accidents happened. Imagine working on the 30th floor and hearing a shout from above. You look up and see something falling. You have perhaps a second to react, to move, to dodge. Or you don't see it in time and your life changes in an instant, or ends. This was the reality these workers lived with, the possibility that at any moment, through no fault of their own, they could be injured or killed by something falling from the work happening above them. The hours were long. In an era before strict labor regulations, construction crews often worked 10 or 12-hour days, 6 days a week. The sun would rise to find them already climbing to their positions, and it would set with them still working, trying to maintain the incredible pace of construction that the schedule demanded. Exhaustion was a constant companion. Tired workers make mistakes, their reflexes slow, their attention wanders. And in an environment where split-second awareness could mean the difference between life and death, fatigue became its own form of danger. Yet the pressure to maintain speed never relented. The schedule had to be kept, the race had to be won. But why did these men accept such conditions? Why did they return day after day to work that was dangerous, exhausting, and paid wages that, while decent for the time, were hardly extravagant? The answer lies in the economic reality of the era. The Great Depression. By 1930, the Depression had taken hold of America's economy with crushing force. Unemployment was widespread and growing worse. Factories were closing, businesses were failing. Men who had worked steadily for years suddenly found themselves with no income, no prospects, watching their savings drain away while their families went without. In this context, a job on the Empire State Building wasn't just employment. It was a lifeline. It was the difference between eating and going hungry, between keeping your apartment and ending up on the street. For many of these workers, the risks of construction were less frightening than the certainty of destitution if they couldn't find work. They took the jobs knowing the dangers because they had families to feed, rent to pay, children who needed shoes and coats for winter. The calculation was stark: accept the risk or watch your loved ones suffer. For most, it wasn't really a choice at all. It was a necessity, and they approached it with a pragmatic courage born of economic desperation. The builders knew this, of course. They knew that the Depression gave them access to a large pool of skilled workers who were grateful for employment. In some ways, this made the rapid construction possible. There was no shortage of men willing to do the work, regardless of how difficult or dangerous it might be. And yet, despite all these challenges and risks, despite the long hours and the dangers, despite the lives lost and the injuries sustained, something remarkable happened. The project finished ahead of schedule, not just on time, but actually earlier than planned. After all the careful scheduling, all the contingency planning, the building was completed faster than even the optimistic projections had suggested, and it came in under budget. The final cost was approximately $41 million, less than the $50 million that had been initially budgeted. In an era when cost overruns were common on large projects, when delays and complications typically drove expenses higher, the Empire State Building was finished for less money than expected. This achievement was remarkable, a testament to the efficiency of the planning and execution. But it's worth considering what that efficiency meant for the workers. The cost savings came, in part, from the rapid pace of construction, which meant workers pushing themselves to their limits day after day. The ahead-of-schedule completion meant months of intense labor, of long hours and constant pressure. The building's success, measured in dollars and days, was built on the backs of men who had little choice but to accept whatever conditions were offered. Their labor, their skill, their courage, these were what made the efficiency possible. And while the financial success benefited the developers and investors, the workers received their daily wages and nothing more. There's no simple judgment to make here, no clear hero or villain. The developers provided jobs in a time when jobs were desperately needed. The workers accepted those jobs, knowing the risks, making their own informed choices. The result was a building that still stands as an achievement of human capability. But the cost was real, measured in sweat and exhaustion, in injuries and deaths, in risks taken because economic necessity left no other option. When we look at the Empire State Building today, when we admire its height and grace, its place in the skyline and in our cultural imagination, perhaps we should also remember those workers. Remember the 5 whose names we know who died, and any others whose deaths weren't properly recorded. Remember the thousands who risked their lives, who endured long hours and difficult conditions, who built this marvel not for glory, but for wages, for survival, for the chance to support their families through the darkest economic period in American history. They were not heroes in the traditional sense. They were ordinary men doing dangerous work because they needed to. But there's a kind of heroism in that too, in showing up day after day, in doing your job well despite the fear and fatigue, in taking care of your family even when it means putting yourself at risk. The Empire State Building stands as a monument to many things, to engineering and architecture, to the ambition and vision of its planners, to American optimism and capability. But perhaps most fundamentally, it stands as a monument to the workers who built it, who paid the cost in sweat and sometimes in blood, who made the dream real through their labor and their courage. The final push at the finish line. There comes a moment in any great undertaking when the end finally comes into view. When the scattered pieces begin to coalesce into a finished whole. When what has been vision and effort and countless small achievements suddenly reveals itself as complete, or nearly so. For the Empire State Building, that moment arrived in the early spring of 1931, as the last major elements of the structure were put into place. The crown and the mooring mast were the final vertical elements to be completed. These weren't just functional components. They were the building's signature, its defining feature, the part that would give it its distinctive silhouette against the Manhattan sky. The crown rose in a series of stepped setbacks, each level smaller than the one below, creating a pyramidal effect that drew the eye upward. Art Deco details adorned these upper levels, geometric patterns and angular designs that caught the light and gave the crown a sense of elegance despite its massive scale. This was the part of the building that would be visible from across the city, the landmark that would guide people's eyes skyward, and above the crown, the mooring mast. Remember, this tall spire had been added to the design partly to win the height race against the Chrysler Building, but it was also meant to serve a genuine function. As a docking station for dirigibles, those great AI